Let's dive into space. Number 10. The Great Filter. In 1998, economist and physicist Robin Hanson published a paper with a question so simple it seemed almost naive. If the universe is ancient, vast, and filled with potentially habitable worlds, where is everyone? His answer was not comforting. Somewhere between the birth of a star and the rise of a spacefaring civilization, something stops almost everything. He called it the Great Filter. The logic begins with the Fermi paradox, named for physicist Enrico Fermi, who in 1950 asked essentially the same question over lunch at Los Alamos National Laboratory. The universe is 13.8 billion years old, according to data from the European Space Agency's Planck satellite. There are hundreds of billions of galaxies, each containing hundreds of billions of stars. The mathematics of probability screams that we should not be alone. Yet, the cosmos is silent. The disturbing implication is that the silence is not absence. It is a pattern. Something appears to be filtering civilizations out of existence before they can make themselves known. And that filter may be biological, geological, social, or something we have no category for yet. Whatever it is, it operates with near-perfect efficiency across the entire observable universe. The James Webb Space Telescope, launched December 25, 2021, has already detected carbon dioxide, methane, and water vapor in the atmospheres of distant exoplanets, including the sub-Neptune world K2-18b, approximately 120 light-years from Earth. Each discovery, suggesting that the ingredients for life are common, makes the silence louder, not quieter. If life begins easily, then something must end it just as easily. The Great Filter is not a single catastrophe. It is a recurring pattern written into the universe itself, and the most unsettling possibility of all is that we have not yet reached it. Number 9. The Cosmic Speed Limit. In 1905, a 26-year-old patent clerk named Albert Einstein submitted a paper to the journal Annalen der Physik that contained a single, devastating sentence buried inside elegant mathematics. Nothing, he demonstrated, can travel faster than light. At the time, it seemed like a minor physical constraint. It was, in fact, a cage built into the architecture of reality, and every civilization that has ever existed or ever will exist is locked inside it. Light travels at 299,792,458 meters per second, approximately 186,282 miles per second. This is not merely a current technological barrier, the way that breaking the sound barrier once seemed impossible. It is a hard limit inscribed in the structure of space-time itself. As an object with mass accelerates toward the speed of light, the energy required to push it further increases toward infinity. You cannot reach the limit. You can only approach it forever. The nearest star system to our own, Alpha Centauri, sits 4.37 light-years away. A spacecraft traveling at the fastest speed any human-made object has ever reached, approximately 430,000 miles per hour in the case of the Parker Solar Probe, would take roughly 6,300 years to arrive. The Milky Way galaxy spans approximately 100,000 light-years. The observable universe stretches 93 billion light-years in diameter. In 1994, physicist Miguel Alcubierre at the National Autonomous University of Mexico proposed a theoretical workaround, a warp drive that compresses space ahead of a vessel and expands it behind. The mathematics are valid. The problem is that the design requires exotic matter with negative mass energy density, a substance that has never been observed and may not be physically possible. The universe is not merely large. It is large in a way that appears specifically and mathematically designed to keep everything within it permanently apart. Number 8. Galaxies vanishing forever. In 1998, Two independent teams of astronomers set out to measure how quickly the universe's expansion was slowing down. Both teams expected to find deceleration. Both teams found the opposite. The universe's expansion is accelerating, driven by an invisible force now called dark energy, and the long-term consequence of that discovery is something that neither team initially announced, because it was almost too strange to state plainly. The universe is actively shrinking itself around us. The teams were led by Saul Perlmutter of the Supernova Cosmology Project and by Brian Schmidt and Adam Rees of the High Z Supernova Search Team, work that earned all three the Nobel Prize in Physics in 2011. Their discovery showed that space itself is expanding at an increasing rate. Beyond a certain distance, currently estimated at approximately 14.3 billion light-years, galaxies are receding from us faster than the speed of light. Not because they are moving through space faster than light, but because the space between us and them is growing faster than light can cross it. The observable universe currently contains an estimated 2 trillion galaxies, according to a 2016 analysis led by Christopher Consolis at the University of Nottingham. In approximately 150 billion years, every single galaxy outside our local group will have accelerated beyond our cosmic event horizon. They will not merely be unreachable. They will be invisible, their light never able to cross the expanding void between us. Civilizations that arise in the far future will inherit a universe that appears to contain only a small cluster of nearby galaxies. The cosmic microwave background, our earliest observable evidence of the Big Bang, will have redshifted beyond any instrument's ability to detect it. They will have no way of knowing the rest of the universe ever existed. The cosmos is not static. It is erasing itself, galaxy by galaxy, from the inside out, and there is nothing in the laws of physics that can stop it. Number 7. The observable universe cage. Every observation ever made, every signal ever received, every photon that has ever struck a telescope mirror or a human retina has come from within a bubble. That bubble is approximately 93 billion light-years in diameter, centered on Earth. Not because our planet is special, but because the universe is only 13.8 billion years old, and light can only have traveled so far in that time. Beyond the edge of that bubble, for all practical purposes, reality ends for us. Not because space ends, because the universe began, and time is limited, and light is slow. The cosmic event horizon, the true boundary beyond which we can never receive any information even given infinite time, sits at approximately 16.5 billion light-years away in the standard cosmological model. This is distinct from the observable universe's radius, because dark energy is accelerating expansion, and the horizon is actually shrinking in terms of the fraction of the universe it encompasses. More of reality is becoming permanently inaccessible with every passing second. What lies beyond this horizon is not empty. Inflationary cosmology, the leading theory of the universe's earliest moments, predicts that the total universe is incomprehensibly larger than the part we can observe. Some models suggest it could be 10 to the power of 23 times larger than our observable bubble, though the true figure may be effectively infinite. There are likely structures out there, galaxies, civilizations perhaps, phenomena we have no framework to imagine, and we will never receive a single photon from any of them. The Planck satellite, operated by the European Space Agency between 2009 and 2013, mapped the cosmic microwave background, the oldest light we can ever observe, from approximately 380,000 years after the Big Bang. Before that moment, the early universe was opaque to light. Whatever happened in the first 380,000 years is permanently hidden. The information does not merely predate our instruments. It is causally inaccessible forever. Every civilization in the universe, no matter how advanced, lives inside its own bubble of knowable reality, and no two bubbles will ever fully overlap. Number 6. The Boltzmann brain trap. In the late 19th century, Austrian physicist Ludwig Boltzmann was wrestling with one of the deepest questions in thermodynamics. Why does the universe have a direction of time? Why do things always move from order to disorder rather than the reverse? His attempt to answer that question using statistical mechanics led him somewhere deeply unsettling, a place where the nature of consciousness itself becomes suspect. Modern cosmology has made his conclusion considerably worse. Boltzmann's insight was that a sufficiently large and sufficiently old universe would, through random quantum fluctuations, occasionally produce ordered structures spontaneously from disorder. The probability is vanishingly small for any given region, but in an eternal or near-eternal universe, even vanishingly small probabilities become certainties. In 2004, physicists Andreas Albrecht and Lorenzo Sorbo formalized the most disturbing implication of this logic in a paper titled, "Can the Universe Afford Inflation?" A random fluctuation could, in principle, produce a fully formed conscious observer, complete with false memories of a life lived and a universe observed. They called it a Boltzmann brain. The problem is not merely philosophical. In several serious cosmological models, including those involving eternal inflation and de Sitter space, Boltzmann brains are not just possible, but statistically inevitable, and they would vastly outnumber evolved biological observers like human beings. If that is true, then most conscious entities in the universe are momentary illusions, flickering into existence for an instant, surrounded by false perceptions of a reality that does not exist around them. The trap is this: there is no observation you can make, no experiment you can run, no measurement that can definitively confirm that your memories, your instruments, and your perception of the universe correspond to anything real. The universe may be structured in such a way that the most common form of consciousness is also the most deceived form of consciousness. If the universe produces more illusions than genuine observers, there is no method available from inside the illusion to determine which one you are. Number 5. The simulation boundary. In 2003, philosopher Nick Bostrom of Oxford University published a paper in the Philosophical Quarterly that presented 3 possibilities, exactly one of which must be true. The first, virtually all civilizations capable of creating realistic simulations of minds go extinct before reaching that capability. The second, virtually all such civilizations choose, for whatever reason, not to run simulated minds. The third, we are almost certainly living inside a simulation right now. Each option is disturbing. The third is the one that kept physicists reading. Bostrom's argument is not science fiction. It is a probability argument. If even one civilization in the history of the universe has run detailed simulations of conscious minds, the number of simulated minds would quickly come to vastly outnumber biological ones. In that case, a randomly selected conscious entity is almost certainly simulated. The logic is straightforward, and, as far as anyone has been able to determine in the 2 decades since the paper's publication, difficult to refute. In 2012, physicist Silas Bean and colleagues at the University of Bonn published a paper titled "Constraints on the Universe as a Numerical Simulation," noting that a universe running on a computational substrate would be expected to show specific artifacts: a fundamental minimum length scale, a hard speed limit, and the quantization of energy into discrete packets. Our universe has all 3. The Planck length, 1.616 times 10 to the negative 35 meters, is the smallest meaningful unit of distance. The speed of light is an absolute limit. Planck's constant, 6.626 times 10 to the negative 34 joules per second, governs the quantization of energy. None of these observations prove the simulation hypothesis, but they are precisely what you would expect if the universe were running on a computational substrate with finite resolution. Physicists including Stephen Hawking and Neil deGrasse Tyson have stated publicly that they consider the hypothesis non-trivially plausible. The most terrifying prison is one whose walls are indistinguishable from the laws of nature, because you cannot escape laws you cannot see past. Number 4. The false vacuum catastrophe. Somewhere in the universe, right now, a bubble may already be expanding outward at exactly 299,790,2,458 meters per second. It has no color, no mass, no temperature in any conventional sense. It is a region where the laws of physics are different, spreading through space at the speed of light in every direction simultaneously. If it reaches us, there will be no warning. There will be no time to react. There will be no event that follows it, because the concept of events as we understand them will cease to apply. This is not speculation. It is a direct consequence of the standard model of particle physics, substantially sharpened by the discovery of the Higgs boson at CERN on July 4, 2012. Measurements of the Higgs boson's mass, approximately 125.1 billion electron volts, combined with the mass of the top quark, suggest that the universe's vacuum may be metastable. This means our universe is sitting not at its lowest possible energy state, its true ground state, but at a local minimum, a kind of cosmic false bottom. A 2012 paper by Galaxies and colleagues in the Journal of High Energy Physics confirmed that this metastability is consistent with current measurements. A vacuum decay event would begin as a quantum fluctuation in some region of space, a spontaneous collapse of the Higgs field to its true minimum. From that point, a bubble of true vacuum would expand outward at the speed of light. Inside the bubble, the masses of all elementary particles would be different. The constants governing chemistry, atomic structure, and nuclear physics would change. Nothing resembling matter as we know it could exist inside it. Because the bubble travels at exactly the speed of light, no information about its existence can precede it. Light cannot outrun light. There is no detector, no telescope, no early warning system that could give any civilization any notice. The probability per unit volume per unit time is extremely small, but in a universe this large and this old, probability is a poor source of comfort. If the reset has already begun somewhere in the universe and is traveling toward us at the speed of light, the question of whether we can detect it in advance has only one answer. Number 3. The heat-death horizon. The universe has a final state. This is not mythology or metaphor. It is a direct, mathematically rigorous consequence of the second law of thermodynamics, first described in the context of universal entropy by William Thomson, known as Lord Kelvin, in a paper published in 1852. Every discovery made in the 170 years since has confirmed the direction of travel. The universe is winding down, and the end state is not dramatic. It is the most complete and permanent silence imaginable. The second law states that entropy, the measure of disorder in a closed system, always increases or remains constant. Applied to the universe as a whole, this means that every process that converts energy from a useful form to a less useful one is irreversible. Every star that burns is cashing in a finite account. According to standard astrophysical models, the last stars are estimated to exhaust their fuel in approximately 10 to the 14th years, 100 trillion years from now. After that, no new stars will form. The sky will be dark. What follows is a period of almost incomprehensible duration dominated by black holes, the last complex gravitational structures. In 1974, Stephen Hawking demonstrated mathematically that black holes are not truly permanent. They emit thermal radiation through a quantum process now called Hawking radiation, slowly losing mass over time. The most massive black holes will evaporate completely in approximately 10 to the 100th years, a number called a googol, a timescale so vast that the current age of the universe is not even a rounding error by comparison. The final state of the universe is a near uniform expanse at a temperature infinitesimally above absolute zero, which is negative 273.15 degrees Celsius. no gradients of energy will remain. No information processing will be possible. Not merely life, but the physical conditions required for any event distinguishable from any other event will be gone. The universe does not need to imprison life with walls or horizons. It simply needs to be patient, and it has all the time that will ever exist. Number 2. The information paradox. Nothing escapes. In 1974, Stephen Hawking published a short paper in the journal Nature titled Black Hole Explosions, in which he demonstrated, using a combination of quantum mechanics and general relativity, that black holes slowly emit thermal radiation and gradually lose mass. The physics community celebrated. Then, quietly, theorists began working through the implications, and what they found threatened to collapse not just our understanding of black holes, but one of the most fundamental principles in all of physics. The problem is information. In quantum mechanics, a principle called unitarity holds that information is never destroyed. The complete quantum state of any system at any moment contains, in principle, all information about its past and future. It is one of the load-bearing pillars of the entire theoretical structure. Hawking radiation appears to violate it. The radiation emitted by an evaporating black hole is thermal, meaning random, carrying no information about whatever fell in. When the black hole finishes evaporating, that information appears to be simply gone. An event horizon, the boundary beyond which nothing escapes, is not a surface in any physical sense. For the supermassive black hole, Sagittarius, a star at the center of the Milky Way, which carries a mass of approximately 4 million suns, the event horizon spans roughly 12 million kilometers in radius. For M87 star, the black hole imaged for the first time by the Event Horizon Telescope collaboration on April 10th, 2019, with a mass of 6.5 billion solar masses and located 55 million light-years away, it is considerably larger. In both cases, anything that crosses that boundary becomes causally disconnected from the rest of the universe forever. Gerard 't Hooft and Leonard Susskind developed the holographic principle in the 1990s, suggesting that all information within a volume of space is encoded on its two-dimensional boundary. Juan Maldacena's ADS/CFT correspondence, published in 1997, offered a mathematical framework in which information might be preserved, but no complete universally accepted solution to the information paradox exists as of today. If information can be destroyed, then the universe is not merely a physical prison. It is a prison that systematically and permanently erases the record of everything that ever entered its most extreme structures, and the most fundamental thing any conscious entity is made of is information. Number 1, the cosmological constant, trapped by the shape of nothing. In 1917, Albert Einstein added a single term to his equations of general relativity to prevent the universe from collapsing under its own gravity. He called it the cosmological constant, denoted by the Greek letter lambda. When Edwin Hubble's observations confirmed in 1929 that the universe was expanding rather than static, Einstein reportedly described the constant as his greatest blunder, a term he had introduced unnecessarily. In 1998, Saul Perlmutter, Brian Schmidt, and Adam Rees discovered that it was not a blunder at all. It was real, it was active, and its implications were far more disturbing than anything Einstein had imagined when he first wrote it down. The accelerating expansion of the universe, confirmed independently by the High Z Supernova Search Team and the Supernova Cosmology Project, requires a positive cosmological constant. This constant is now interpreted as the energy density of empty space itself, what physicists call vacuum energy or dark energy. It constitutes approximately 68% of the total energy content of the universe, according to data from the European Space Agency's Planck satellite published in 2018. Ordinary matter, every star, planet, galaxy, and living thing accounts for approximately 5%. Dark matter accounts for approximately 27%. The force that is tearing the universe apart and sealing us inside an ever-shrinking, observable horizon is not a thing moving through space. It is a property of space. It is what emptiness is made of. Here is where the physics becomes genuinely vertiginous. Quantum field theory, our most precisely tested scientific framework, predicts that the energy of empty space should be approximately 10 to the 120th times larger than the value we actually observe. The number 10 to the 120th is not a large number in the colloquial sense. It is a number so incomprehensibly vast that the ratio between the predicted value and the observed value has been called by physicists the worst prediction in the history of science. We do not understand why the cosmological constant has the value it has. We only know that if it were even slightly larger, the universe would have expanded too rapidly for galaxies, stars, or planets to form. If it were slightly smaller or negative, the universe would have collapsed before life could arise. It sits, with impossible precision, in the only range that permits us to exist. And what it is doing, with that precisely tuned value, is building a permanent, inescapable, expanding wall around everything that exists. The de Sitter horizon, the maximum distance from which we can ever receive a signal in a dark energy-dominated universe, is shrinking in terms of the fraction of the cosmos it encompasses. Every second, more of the universe crosses permanently beyond our reach. In the far future, the expansion will accelerate further, eventually tearing apart not just the large-scale structure of the cosmos, but galaxies, solar systems, and ultimately, in some models, the atomic bonds that hold matter together in an event called the Big Rip. We did not fall into a trap. We were born inside one. The cosmological constant was present at the first moment of time, woven into the geometry of space-time before a single particle existed to be affected by it. The cage has no walls you can touch, no bars you can see, no lock you can study. It is made of the same nothing that fills the space between every atom in your body, and it has been expanding since before the first star ever burned. Every law of physics we have ever written, every telescope we have ever built, every thought any mind has ever formed in the history of this universe has occurred inside a structure whose most fundamental property is the energy of absolute emptiness, tuned with a precision we cannot explain, to an effect we cannot escape by a mechanism we do not understand. If you want to see more videos like this, click the video on screen now and make sure to subscribe.